Okay, hello everybody. Welcome to this Q&A video for the fourth week. Again, not that many questions this week, which is fine. The first question we had was kind of asking about the future math content of the class, how mathy is the rest of the class going to be. There were some partial derivatives in the last video, and the good news is that that's pretty much the peak of the calculus that gets used in this course. We're not going to be doing any more optimization, for example. That actually might be the end of calculus used in this course, except maybe when we do nonlinear regression models after the midterm, we might end up taking one or two very simple derivatives, but definitely no more partial derivatives and definitely no more optimization. So if that confused you, the good news is we won't have to do anything else like that. The proofs using calculus like that, the optimization problems probably won't show up on the midterm, and if they do, only the the later steps of them will, where you are able to turn the result into the ratio of covariance to variance, for example. So if the calculus scared you, good news, there's not going to be that much more calculus. The second question people had was talking about more information about the midterm and the paper. The paper we'll talk more about after the midterm. Maybe we'll talk a little bit before the midterm. I want to get a little bit more building done on kind of the tools of econometrics, because then what I'm going to do is a couple of times I'm going to show you different data sets that you can use to find data for your research questions. So not this coming week, but the week after that, I think I'll show you the general social survey, and I'll do an example research question there. So for now, just kind of think about, if I had to do an empirical research paper, what would I do it on, and kind of narrow it down to a few causal questions that you could presumably test using. You could realistically test them using data that's actually out there. So, we've looked at examples in class of, does healthcare cause health? Does spanking your kids cause them to be rotten adults? Do police keep us safe? Questions like that. So just simple causal relationships, and they don't have to be as policy relevant. So one student last semester wanted to know if having more pets made you happier. All right, that's a causal question, and she was able to use data from the general social survey. And again, very simple question, but it got her a very good grade on the final paper. But as for the midterm's coming up in a few weeks. I will hopefully try and schedule a kind of live review session for you guys to come in and ask your questions via Blackboard Connect. But in the meantime, in the assessments folder on Blackboard, I've posted last semester's midterm. So you can take this as many times as you want. Like, it doesn't count towards your grade, but this is your chance to kind of look at the questions I asked last time. Again, you probably won't understand all the questions yet, but as you get close to the midterm, you can kind of use this to gauge the kinds of questions that'll be on the exam and the kind of material you should be familiar with. Okay, so we talked about calculus, talked about the midterm, talked about the paper. The last thing was was a question about the second problem set, which I'm glad was asked. And what they noticed was we're using our life expectancy data here. And what the student noticed was that if you do the regression, you regress life expectancy on safe water, you get this equation, right, with this coefficient and this constant. But then if you find the means of the data, so we'll sum our two variables, all right, there's our means here. If you remembered correctly that the formula for the intercept is we take the mean of our independent variable, which is safe water, so we do 76.1, multiply it by our slope, which is 0.238561, and then we're going to subtract this from our mean of our dependent variable, which is life expectancy. Okay, and we want to subtract that 18 from there. 18.154. Okay, we get 54.12, yeah, 54. But here it's telling us that the coefficient is, that the constant is 53. All right, so like what gives? Are we doing something wrong? And the answer here is that our data set is actually incomplete. Okay, so for one, if you say this in your problem set, I'll still give you full credit. It's way within the confidence interval. Like it's not actually going to affect your um, outcome, and you still are showing me that you know how to use the formula. But just in case you were curious why it's giving you different results, a lot of the safe water values are missing. And the way Stata works is that if any of the variables that you if any of the variables that you ask it to include in your regression model are missing observations, it drops those observations from the analysis. So even though they have life expectancy observations, if they're missing safe water, they won't be included in the regression. So we can see this where there are 68 countries in our sample, but if we look up at this regression, it tells us that it only observed 40 countries. So watch what happens here. We're going to summarize our variables again. You can see here there are 68 observations for life expectancy, but only 40 for safe water. So here what we're going to do is we're going to summarize them if life expectancy is not, that's what the exclamation point equals, that's just, the equal sign with the line through it. It's not period, meaning missing. All right, and what is it giving me? Oh, if LXP, we want if safe water, whoops, I forget I can't use the page up key. Anyway, da-da-da-da-da, safe water is not missing. Again, forgetting how to type. Okay, missing. Okay, so now notice that our mean went down by just a little bit. But now if we plug this into our calculator, this time we want to do 71 point that times our coefficient. All right, and we'll add this to the memory. And now we'll just subtract. Or sorry, we were doing that wrong. We wanted to multiply our independent variable, which was safe water. So sorry, 76.1 times 0.238. Okay, and then we subtract 71.475 minus 18.1118. 53.3, 53.3, and I truncated the decimals, so that's why it's different past there. Okay, but if that student was confused, very astute of him to notice. So that's why you're getting different results, because you're summarizing all of the values of life expectancy when we're dropping some from our observation, from our regression, because safe water is missing some. Okay, I think that was most of the questions this week. Next week, we're going to talk about, or I guess this coming week, Monday, we're going to talk about unbiasedness and variance. It's going to be hopefully the last really technical, math-heavy lecture where we're just kind of doing proofs. Although I did manage to find a Simpsons clip, someone mentioned that. And then we'll talk about multiple regression, and that's where, we can get more interesting topics, applying it to actual causal questions like we did with randomized controlled trials. So I hope you look forward to those. Please don't hesitate to ask more questions, even if the question is just, could you clarify this material, go over this topic again. Have a great weekend. I will talk to you soon.